Hello everyone and welcome again. So we've managed to do a render of the procedural dissolving effects that we've made together, and I included points that are inside the volume, just playing the sequence in reverse. And this is rendered using Mantra. It took some time because I didn't tweak settings, but I let it run overnight and this is what I have. So let me play it in the correct order. And I think it's working. There's few tweaks, obviously, but again, we don't have any sim. And the next part I want to talk about is volume simulation in Houdini. We can get so many details with pops, with noise, with procedural techniques, and pretty much all the tools we have. But we're gonna hit a limit where we're not getting enough motion, especially when we want something that it looks like a fluid like motion. And getting all those wispy things is done only via volumes or via some kind of simulation before the actual sim. And except these two examples, all of these examples, or any complex particle sim or particle motion is going to have some sort of volume. So I think it's very, very important to understand this concept and understand how to prep this data. And we're going to use the Dragon head dissolving to learn about volume and create volume effects. And then we're going to use them in the sim and move from there. I think it's going to help us build a good understanding of Houdini. So let me create a GeoNode, a new context, and let me import the Dragon head. And let's call this volume experimentation. All right, let's import the Dragon head, and this is what we have so far. So we've created a VDB off of this, which looked like an SDF, which looked like a surface, and that is an SDF. So this is what it looks like. We can also change this to look like a density. And I want to move this so that the bottom of the dragon statue is at 0, 0. So it's easier for us to create collision and things like that. All right. So now we have a volume representation of the dragon. I'm going to create a null, and this name is called density, right? So the volume, the main volume data or the scalar field that we need needs to be, we can name it whatever we want, but the default in Houdini is density, and it needs to be a float. That's the minimum requirement to create a smoke sim. Out smoke source. I'm going to create a DOP network, and I'm going to call this smoke sim and give it a red color. And I'm going to dive inside, and like we created the pop source, the pop object, and the pop solver, we're going to create similar nodes, similar setup to deal with volume. And the first one is going to be a source, a sparse object or a smoke object. And if you type in smoke, you will see you have smoke object sparse. And we can also use a smoke object sparse. We can also use a smoke object. The sparse is going to work with the newer solver of Houdini 18, I believe 18.5, 18. So we're going to use that. This is our container, data container. And just place it, and you have a box displayed in the center. Next thing is we're going to use a smoke solver. And if you type in smoke, you have a smoke solver, which is the older version. And then we have a smoke solver sparse. And this is a newer version. And then we need a source. The source for this is called volume source. And it's not specific to smoke. It's also used for flip and various other things. So that's why it's generic. Anything that is volumetric data, it can come through this. And I'm going to call this smoke source node. And here, as usual, the first one, the gray node, goes into the gray node. And this is the mixer. This is the engine that's going to take this container, fill it with this data, and then give us the result. So all I want for this now is to take that dragon head and emit smoke off of it. And I want to create a ground and collide with this ground. So I'm going to create a ground plane, merge it, and connect it here. And this merge order is very, very important, because if you go to the effector relationship, it says left effect, right input. And it's very important that the left goes in first, always at the top. The second is the smoke. So let's connect this. And then, sorry, the next three options are called advection, sourcing, and forces. So obviously we want to connect this to sources, and we need to plug our smoke. So let's copy the path, paste it here. Right now this node is not initialized to do anything. It's just empty. It looks like it's set up to do smoke, but it's not. And this drop down here is like a preset of things that this node can do. So we can import a flip sim, water sim, we can import a source ocean, we can also import smoke. So to actually trigger it to initialize the UI to work for smoke, we have to change it to something and then change it back. So I just set it to collision and then change it back to smoke. So I believe we can do this as well. So volume, let's click here. Yeah, it doesn't trigger, see? So we have to change it to something and then change it back to smoke, and it will initialize the node. So what did it do? Well, it created three channels, three default channels that Houdini expects. First one is density, and this is the source. Where is it coming from? And this is the target. So we can have data in SOPs, call it whatever we want. But here, when we import that data, we have to tell the solver where we're going to copy this data, where we're going to put it in. So the density, which happens to be the same name in SOPs, is going to go into density. And this is the operation. How do you want the data to be combined with the existing data in the solver? So we can choose various operation here. The default for density is add, and same one for temperature, and for for temperature and for velocity. We don't have both of these, so I'm gonna remove them for now, and I'm gonna hit play. And you can see we have smoke being emitted, and it's getting denser and denser and denser every frame. And see, this bounding box domain is expanding based on how much volume data there is, but it's taking few frames for it to work. So what we need to do is we need to change it on the first frame to account for this size. So you can see the data, it's taken few frames for it to expand. And the reason for that is because this is adaptive. So the domain is actually changing, and any smoke sim or water sim will need a domain to operate under. It's not like a particle sim. Particle sim happens in everywhere. Or a grain sim, it's not limited to specific location. But smoke it needs a domain. So this domain is trying to expand to accommodate all the data, but it's not doing a great job because the first 5 frames are basically gone. So what we need to do, and you have to always be aware of this, is you need to tick on enlarge fields to contain source. And now when we hit play, you can see it pops right away. And then continuously emits smoke. So let's add gravity force here. And some of the things that we did with pop were pop, for example, we were connecting them here. This is different. Okay, this is working with voxels, and the gravity is going to happen after the solver using the gravity node. This also works for pops and any other type of sim. And by adding the gravity, you can see now we have a sim. We had a sim before, but there was no forces being applied to it. The next thing we can do is we can start adding some noise to all of this. So we can add a gas turbulence noise and connect this into a force, and we can scale the force here. And I'm gonna lower the gravity to -2, so it's not too strong. And now with that noise, you can see we're getting cool movement in the smoke. But we're not gonna be creating awesome sims at the moment. We're simply gonna create something that looks interesting to use as a force to drive the particles. Okay, so let's say I have this sim. Let's increase the swirl size, something like that. And I'm going to make the smoke dissipate over time. So let's put a gas dissipate node. And here I'm going to combine them. This is also treated as a force. So I'm going to put down a merge node. And I'm going to say the evaporation rate is 0.3. So 30% basically every frame. And now if we hit play, the smoke is going to start disappearing after a certain period of time. We can make it stronger, 0.6. Yeah, I can see it here, it's dying now. And I'm going to lower the amount of force here and combine it with another one. So instead of just a small one, I'm going to add one that has a bigger value, a bigger force size, and a lower amplitude. So basically getting some more breakups happening here. All right, so we have this sim. Let's import this data out of the solver. I'm going to do that using an import fields node, and this is specific to work with smoke or fluids or water. And I'm going to drag the solver. I'm going to copy the name of the node that we want to import the data from, and then we choose the type. So I'm going to import smoke, and all I'm interested in is density and velocity. So if I hit play, the data is coming in and it is cached to disk. So I'll increase the cache here to 25 in case we need to cache more. Right, and if I middle click, you can see we have density and we have velocity field. It's made of 3 components right now, and this is a volume data, and this is not VDB volume, this is Houdini native volumes, and I prefer to work with VDB all the time, so I'm going to use a VDB, a post-process node, sorry, to simplify this, a Pyro post-process node, and say convert to VDB and combine volumes. And now it's gonna, because Houdini volumes does not support vector fields, only VDB does. And if you middle click now, you see you have VDB type and you have density and val. This is much cleaner to work with. So let's use a scatter node, and let's scatter points here. Let's say 10,000. I'm gonna create a pop network, and this is basically a DOP network with predefined, pre-set up PopNet. So instead of building it by hand, you get this created by default. Let's call this pop source. I'm gonna copy the name, the path, and here say I want to use not dop object, parameter value, and hide the source. If we go to the first frame, change it to all points. If we hit play, nothing is gonna happen. And what I want to do is I want to create a pop advect by volume. What this does is it takes in volume data and use it to move the points of our particle sim. I'm going to say out smoke val, and we don't need density, we only need velocity for this to work. So I can uncheck this. I just need velocity field, and then here I'm going to point it to where that data is coming from, and then the name of the field. You can name it whatever you want. The default is val. And we have a few different modes. I'm going to use update velocity, and now if we hit play, you will see that the particles are moving following the smoke motion. And this is the key to creating natural particle sims, because you can get so much details with the default pop forces and all of this, but really the natural motion, all of that is going to come from this. So let's put down a ground as well and connect it here, and let's go back, let's hit play, and now we have that smoke, that pop force being applied as well as the smoke sim, and you can see it's gonna basically work as a force on top of the points that we have. All right, let's learn a bit more about volumes in general. I'm going to take this dragon, I'm going to clip it along the z-axis or x-axis. Let's do the x-axis. I'm going to do a polyfill and set this to triangle, and then do the same thing here, VDB from this data, and I'm going to call it temperature. I'm going to take on fill interior as well, and same here, fill interior. And now this, if I middle click, it's called temperature. I'm going to merge this data, this field, with my density. Okay, so now I have density and temperature, and let's go back inside and let's hit play. Nothing is happening, and let me disconnect all this Let's just leave the gravity and disconnect all the forces and all of that. And let's go to the source. And what I want to do is I'm going to click the plus button and set this by hand. So I want to import the temperature field, and I want to plug it, and I want to copy it into the temperature field of the solver. And now if I hit play, we're going to see something different. We're going to see that the left side is rising up and the left side is staying intact. If we go to the smoke object, I'm going to turn off density. I'm going to click multi-field and go to the multi-field tab, type in density here so we can visualize that. Let's increase the density to 10. This is just a visualization. And then under the emission, I'm going to set this to 1 and type in temperature. And right now it's showing up as white. I'm going to copy this name and paste it here as well. You can see we're getting some colors displayed right now. So let's change this to a clamped ramp or periodic ramp clamped. And let's pick a black body. And I'm going to change this these two colors to have better tones, something like that. And again, this is just a visualization process. And let's increase this emission to 10. And if we hit play, you can see that half of the sim is rising up and the other half is falling down. All right, let's go back. So instead of using just half of this, I'm going to do it again on this node. And now it's called temperature, but it's everywhere. It's an exact copy of the density. But I don't want them to be exactly the same. I'm going to use a noise, volume, noise, fog. This is a fog volume. And this node will basically add noise to our volume. And it needs to know the name of the field. It's called temperature. And I'm going to change it to zero centered. So I get more noise or more breakups in it. And now if I merge it, I have a uniform density and a noised up temperature field. And let's go inside and run the sim again and see how that looks. Very cool. So now we have the fire coming in and emitting smoke, and this is basically how you get a smoke sim with or like an explosion or any type of fire effects. And you can see the parts that don't have smoke in them, they are not rising up, but they will eventually get hotter because the temperature will transfer and affect everything. So where does this control for like how fast it rises and how fast it cools? They're all located here. And what I'd like to do is I'd like to set the reference, I believe, to 1. This one to 1. Let's try it like this. Yeah, so I'd like to set this to 1, and I only have one control to choose how much rising or buoyancy we have. So let's set this to 1.5 or to 2, and then we can change the buoyancy scale to affect how far the smoke goes up or how strong the buoyancy force is. Let's make it go up more. Let's hit play. And let me tweak the result. I'd like to see more patterns here. So I'm going to take on emit range and copy this and take it here as well. Paste relative reference and say my range goes between 0 and 10, 0 and 5. You can see now we're getting nicer display of the temperature field. All right, let's go back here. And I'm gonna play with the cooling rate and set it to something really high. And what this does is it's gonna make the smoke cool down much quicker, and basically it's gonna stop rising up eventually and fall down because of the gravity. Okay, let's connect this smoke source and let's hit play. And now we're adding a noise and we're making our object emit fire. And this is very, very cool. So we can use this force now, same way. We can apply it to our particles and hit play, and they're all gonna follow the object nicely. But this is not what I intended to do. I wanted to explain how all of this works, but I want to create something that looks interesting that we can use as a force. So what if instead of pushing all this data to the up, we're going to push it to the right along a different angle. But here it's not allowing us, there is no angle for where the temperature goes, where this buoyancy goes. So what I'm going to do is I'm going to use a node called gas buoyancy. And this is basically how this node is working. And I'm going to lower this to 0.1. I still want some rising up, but not so much. And then here, you see we have access to the buoyancy direction. I'm going to change it to 1 and 0. And I'm going to set this to 4. And it's based off the temperature. And let's see how this is going to look. And boom. Now we have something pushing in this direction. And we're getting some cool motion overall. I'm going to introduce some wind as well. Let's see. And that wind can be located here under the smoke object fields. And there's a wind tunnel. I'm going to set this to 2. And this is different than a uniform wind tunnel or a uniform force because it is based off of the temperature. So some areas are hot, some areas are cool, and it's changing over time. So the effect is a bit different. I'm also going to lower the cooling rate because I think it's too high. And I'm going to add some diffusion, and this will simply blur the result of the sim. All right. And let's take a look at this. And instead of using our scatter source, I'm going to go to the previous node that we've made. I believe it's this one. No, it's this one here, pop intro. And we did cache a source where the velocity or the points are animated. So I'm going to use this one. I will probably offset it so it does not start at frame 19. I'll offset at 19 frames so we don't have to wait for too long. And I'm going to object merge this, copy it, and go to the smoke volume experiment, paste it here, and copy this offset so the points line up, and drag this here. I'm going to use a time shift node and offset it by 19 frames, I believe we said. So plus 19. And now we have a frame there. I'm going to change it to 18, 17. Boom. All right. Let's see how this is going to look now. Also, this source has velocity on it. So the actual emission has forces coming. But now you can see the motion is much more organic, much more natural. And I'm going to lower the life expectancy to 3 and the randomization to 0.5. I'm also going to jitter the emission and change the advection to trace midpoints because this is going to be more accurate. Add a pop drag to reduce the amount of force over time to make it feel like it's dragging. And let's copy the import node from here so we don't waste time, which is, I believe, this one we can use. And right now this is all being cached live, so it's all simmed live, so it's gonna add to the overhead, but it's fine for now. So let's hit play, and it's all simming. It's simming the smoke and it's simming the particle sim, and we're getting some really cool particles being emitted. And they don't look great, so let's fix all of that here. And let's take a look at this over a black background. Maybe a stronger way, more visibility. 5, something like that. Yeah, this is much more organic. You can see the pattern. You can see all the cool details happening. And our source, this source here only has the shell, I believe. Yeah, so it only has the shell, and I want to fix it in the next video so that we have some data inside as well, so not just the shell. But let me do a preview of this, and I'm just gonna increase the number of points in the source by using a pop replicate node. And this is gonna do the same thing as in DOPS, yeah, but it's gonna do it in SOPs. So we're not gonna change the sim, we're just gonna increase how many points are coming in. And I'm gonna set it to a line, because this will allow me to stretch it along the velocity vector. So if I hit play, you can see now it's being replicated multiple times, and I'm gonna reduce how long this line is. And under the attribute, we have to make sure that we say copy source attribute, otherwise we lose the data. And now we just increased the number of points by four times. And let me cache this data. I cache 120 frames. And I'm gonna control click here so the name changes. I'm gonna call this pop advected by smoke. And we'll continue in the next video. Thank you guys for watching. See you in a bit.